should get started now. So if I recollect last time, we left off looking at the two major types of data, information. On one side, we had what's called categorical data, and that, if it had some kind of natural order, was called ordinal. And then the other kind of categorical data was, in a way, kind of a whole load of things, but they had no natural order to them, like colors, for instance. And then we had numerical data, which is called quantitative, and it splits into two subgroups. The first one is continuous, and if it isn't continuous, then it has to be not continuous. And one way of thinking of continuous data is, if you take two consecutive numbers, can you still get any of the values between them? And if the answer is yes, at least theoretically yes, then it's continuous. And if the answer is no, then it's not. So continuous data would be things like you measured people's heights or weights, and not continuous data would be you measured how many coins they had in their pocket or how many children they had or something like that. So what we're going to move on to today are two new types of variables. They're called explanatory variable and response variable. A variable is just a thing in mathematics or something that has various values. So essentially what you do in these stories is that, in some situations at least, you collect information, but they're paired together in some way. So you might, for instance, collect data where you ask someone their age, and then you found out what their height was. So those would be called variables. Age is a variable, right? I'm 24, I'm 16. Height is a variable, I'm 62 inches, I'm 71 inches. And these two variables, one of them is called the explanatory variable, and the other is response. So let's pretend that this data was from high school students. Either age or height will be the explanatory variable, and the other one will be the response. The explanatory variable is the one that at least partially explains. So explanatory explains what the response variable is. Can you imagine that if you looked at that data, wouldn't there be some connection between the age of that student and the height of that student? In other words, 14-year-old students are typically smaller than 18-year-old students, right? So in that world, this guy here is called the explanatory variable, and this one here is called the response variable. It's sometimes you have to be kind of careful about reading the story. There's always going to be some kind of story attached to it. And when you read the story, you have to think carefully, which one of them is kind of explaining what the other value is. And I'm trying to close something here. Right, there we go. Let's try another example then. Suppose we collected data, and the data was, are you, let's keep it simple, self-identified males or females. And on the other variable, it's, are you in favor of higher taxes? And the response that people gave to this is, we'll keep it very simple. Yes, I'm in favor of higher taxes because I think they pay for things, and nope, I'm fed up giving them money. So two different variables. One is the sex of the person that you asked, and the other one is, are they in favor of higher taxes? And you might find that males are against taxes. They say no a lot more often than, say, females. Now, in this story, what you have to decide now is, and it can be difficult, which one of them is the explanatory variable? Which one in some way helps you understand or explain what the second one is?
Is it the sex one?
I would say yes. Sometimes you will enter a question where it's not obvious which one is which, right? You know, for instance, suppose you went in hard. So let me give you one where I don't think it's easy or even possible to decide which is explanatory. Because once you know that guy, whatever the other one is the response, right? You don't have a choice. So here's one that I think is very grey, and I'm not so sure what the answer is. Suppose you collected data on the height of a person, how tall they were, and the shoe size. So you collected data on 100 people and you got how tall they were and you got your shoe size. I'm a size 5, I'm a size 7. You could argue that the height of a person does affect their shoe size. In other words, tall people tend to have big feet and shorter people have small feet. Agree? If you decided that, wouldn't you make this explanatory and that the response? Couldn't you kind of turn that on its head a little bit? Can you say people with big feet tend to be tall and people with small feet tend to be short? In which case you're saying this fella is the explanatory and that one is the response. Do you see that it's really quite hard to decide in that situation there, at least, which one is more likely to be the explanatory than the response? I'm pretty sure that the homework in general makes them clear. You know, it's a little bit more obvious. But let's go back and turn some of these on their height. If I decided that height was the explanatory variable, in other words, tall people tend to be older than young people, couldn't you argue that you could switch places with these? So then if you have that, because there's very often, oh yeah, I could switch it. Which one is probably the stronger connection? Would you agree that age is probably a stronger indication of how tall you're going to be than your height? Because couldn't I find a 62-inch person who's 50 and a 62-inch person who's 20, right? Can you see that their height isn't as strong an influence as it would be on their age? If you did this one here, I think you might be able to switch them around, but I think this direction is a little bit stronger. So yeah, you could argue in a lot of cases, well, you could switch the order. But if you can do that in your brain, try and think of which direction is the strongest, right? Good news is you get 5 guesses. So if you get it wrong, isn't the second one going to be right? So it's not like it will be difficult to find out, but try and understand it the first time round. I'm going to see if I can find the darn questions now. I'm getting all confused. Here we go. Right, just take me a few more moments to get it set up. I think it's ready. Right, was there any questions about what I've just talked about? Or you feel reasonably comfortable about the explanatory versus a response? If you're not sure, hopefully we'll get a couple more shots. Are y'all looking at chapter 2? Is that what you see on your screen? Okay. I think it's around about question 6. Here we go. For each of these, tell me who the exponents and aspartic. Okay, so the score on your final exam, so that's the first set of data. Oh, I got 49 in my final exam. And your final grade, I got a 3.1 in psychology, right? Something like that. Which one of these is the explanatory variable?
The exam score?
I would agree with you. Would you agree? Right. Now, in the next one, your opinion about the death penalty. I'm for it, I'm against it. And your sex. I'm a male or a female, right? Which one of them is the explanatory variable?
The sex?
Right, I agree. You want, in your own words, what made you think that? I agree with you.
I mean, honestly, a guess, but just
Oh,
gender roles, I guess.
yeah, I mean, it just felt right. Sometimes you don't know why you know something, but does it make sense that a male might be more, again, more in favor of the death penalty and a female would be less? And it's male and female that is the strongest influence on the other one. That direction, right? That connection is stronger from the sex to the other way around. Oh, here's one where you get a little pull down. For a pair of variables specified, so the score on the final exam and the final course, well, we did this one. They just phrased it in a different way. So that goes there, and that goes there. Ah, I think that's getting you a different way to answering the question. Okay, here's, hopefully you don't smoke, but you can do what you choose to do. According to the Associated Press, at least back in 1998, smokers are twice as likely as lifetime non-smokers to get Alzheimer's or other forms of dementia. And they did this, or they came to this conclusion by following 6,870 men and women aged 55 and older. For this situation, specify the explanatory and then the response variable. Right. So what is causing what? What is explaining the other?
I would say whether you smoke or not determines the chance of developing the dementia.
Now, in a lot of studies in medical, statistics goes hand in hand. One of the ways in which they prove a connection is that they tend to have two variables. One variable is something that people do, in this case, smoking or don't, right? That's the first variable. And then the second variable is, do they catch this disease or not? Now, not everybody gets Alzheimer, whether they smoke. Not everybody who doesn't smoke doesn't get Alzheimer, right? It's not as clean as that. But isn't there more in one and less in the other? And once you have identified that connection, it would become a risk factor for dementia. So your doctor would say to you something like, you know, you've been smoking for a long time. Do you know you're twice as likely to get Alzheimer if you're a smoker than if you don't? So maybe you should give up smoking, you know, something like that. So the explanatory variable is whether you're a smoker. Right, what kind of variable is I'm a smoker or I'm not a smoker? What name do we give to that type of variable? And I'm talking about categorical or quantitative now.
I'd say it's categorical.
Right, do you see from the choices there? Would you think it'd be ordinal as well? Because some categorical data can be ordinal.
I don't think so.
No. Whenever you get the yes, no, in favor, against, that dichotomy thing, can't you switch them in so there's no natural order? So I would just go categorical as well. That makes whether you get some form of dementia, which is also a categorical data. So as you see in this particular homework, it's kind of fill in the blanks that you might have done in an English lesson where they give you some phrases and you're meant to put in the one that suits the sentence best. Here's another one. Well, let's look at this one then. To answer the following questions, researchers would measure two variables, right? It's the typical way they approach these problems. And for each individual unit in the study, in each case, they specify two variables and whether the variable type of each, and then specify which is explanatory and which is the response. Okay, which story shall I take? I'll pick this one. Individuals in the United States fall into one of a small number of tax brackets based on how much money they make. Is there a relationship between a person's tax bracket and the percentage of income they donate to charities? Okay, so the explanatory variable here is the tax bracket in which an individual falls into, which is a categorical or an ordinal.
Ordinal?
Would you agree that you're in, I don't know what they call them, tax band A or tax band 1, but don't you go like A, B, C, D, highest is at the top and lowest is at the bottom? So, no. Sometimes the answer is ordinal, not just categorical. The response variable is how much they pay, how much they donate to charities, right? So the percentage of their income that they donate to charities. So they might denote 1% to charities, it might be 10% to the charities, right? It's a number. And because it's a number, does it not make it quantitative? Couldn't they have, they didn't in this case, but instead of quantitative, couldn't they have given you a better choice and said continuous or not continuous? Right, now, percentage. Let's suppose that was one of the choices. Does percentage that you donate to charity, is that number continuous, at least theoretically at least, or is it not continuous?
I think it's continuous.
Agreed. Could you donate 9%? You could donate 10%, or couldn't you donate 9.12% if if the money worked out that way? So there are little nuances like that it didn't happen here, but it might happen in a later question. Are we beginning to get a better feel for this explanatory response? The explanatory variable is the thing that you're measuring that has an effect, right? Explains why the other thing is what it is. And now we're going to return and look at something else. Okay, let's suppose that I collected data on Scottish people and we went and asked them. So I haven't room for it. Did they get drunk yesterday? So were they drunk yesterday? And then you have frequency. The answer is I've never drunk, right? Yesterday, I rarely, well, let's not say yesterday. Did you get drunk or do you get drunk? How about that? So, do you get drunk? Never, I never get drunk. And then the second one they said is, I rarely get drunk. And then, I sometimes get drunk. And I mostly get drunk. And then I'm always drunk. And the frequency is, I asked a big bunch of people and the frequency is 5 of them said I never get drunk, 50 of them said I rarely, 25 said that, 15 said that, 20, 30, 40, 50, 60, and 40 of them said that. So this is just basically a pretend survey that we've done. And now what we want to do is we want to try and analyze that to come up with some of the kinds of, ways to set up this information. And the two types of things we're going to look at are how can you show this information instead of a table? How can you show it graphically, right, as a picture? And the other one is that we want to look at this data and we want to look at it in terms of percentages. Now, in this particular case, since I artificially made sure that I asked 100 people, wouldn't you agree that the percentages are dead easy? Because 5 out of 100 would be 5%, and 40 out of 100 would be 40%. What you would want to do if you wanted to do this information graphically is that you would use, in this case, what's called a bar chart. God, you'd probably be, 10 years old when you got to do your first bar chart. They've been there forever and a day. Now, the way that you set up a bar chart is along the bottom, you typically put the explanatory variable, right? In this case, never, rarely, sometimes, mostly, always, right? That kind, right? And then the vertical one is going to be the response. In this case, the response is just, you know, the people who said that. Uh-oh, come out of there, you little girling. Chloe, come on. No, not in the cables. Come on. Chloe, I'm going to have to postpone it a minute. Little bugger's got behind the computer. Come on, let's go. Come on. There she goes. There you go. Come here. I guess I'll just have to learn to keep her in her cage in the start, right? So what we were saying, right? Frequency goes this way, and drinking habit goes that way. I'm doing this really quickly because I'm going to actually show you that we have a piece of software that does them much nicer than I do. And so you might have never, and that would be 5. And then you have rarely, which is 15. I apologize for how untidy this is. Then you have sometimes, 25. Then you have mostly, back down to 15. And then right at the end, you have always, which 25, 30, 35, 40. Whoa, just made it. Way up there. Are you all quite comfortable about what a bar chart looks like? And you can put some heading out here like percentage or frequency of people and how drunk they get. Now, how do you answer a question like this in WebAssign? Because you can't really draw pictures in WebAssign, at least I've never seen how you could do it. Well, what you do instead is, and I'm about to show you, is that WebAssign has a lovely program inside it, and it's called SALT. All I remember is the S stands for statistics. What other 3 letters stand for, I can't remember. So let's show you how that works. Right, so here is a question. This particular one summarizes the frequency of seatbelt wearing amongst 12th graders. And that's kind of scary. 102 of them, and this was a huge sample of 1424. What's that, about 8%. Isn't that because high school students are immortal? You just can't die. Or at least that's their attitude to life. Right, let's click on use SALT button. Now, bring it over here so you can see it. There. Now, when I hit that button, do you see the table is there? Now, along the top, there are certain things you can do. It depends on what the data is. The one I'm going to do is hit charts and graphs. And then if I scroll along a little bit, do you see the one that's called bar chart? Because that's what they want. I'll click on that. Okay, I forgot to select the variable, which kind of should have been obvious, but I forgot to. There I hit the bar chart, and I'm probably going to have to shrink this quite a bit so you can see it. There we go. Can you see it makes a much nicer bar chart than I did? And can you see along the bottom are never wear it, always wear it, and vertically the frequency. So what WebAssign does then, when it asks you that question, so can you kind of imagine what that shape looks like for a second? What they then do is they give you 4 pictures. And would you agree that that picture was like the one I just did? So you do create a bar chart, but you let the software do it. Actually, couldn't you do it by hand and then look at the 4 pictures and pick it that way? I guess you could have done it by hand. But if you want to do it quickly, SALT does the job. Now, suppose you wanted to answer some of these questions now. the percentage type questions. Well, they're not nice and easy because the numbers aren't pretty. Let's take the percentage of people who never wear a seatbelt. Now, write that number down for a second. It's 108 people, 102, I should say. And the total was 1424. So let's show you what that looks like. And then you can figure it, hopefully, you can figure out what to do. If you want to take a number like 102 out of a total of 1424, if you want to make that a percentage, don't you do this guy divided by that guy, and then finally multiply the answer by 100, and that's what gets you a percent. And of course, I'm not even going to try and do that in the head. That's what these damn things here are for. So 102 divided by 1424, and then times by 100, and you get that answer. And they want the answer to 2 decimal places. So I'm going to call that 7.16%. Are you comfortable about taking the data but rewriting it as percentages?
1,424 is the statistic for the always, I thought.
And you are darn right, young man. The moral of that story is to read the darn question. The total number was 2518. That number is not the total, that is the number. So 102 divided by 2518 times it by 100. Well caught, David. So it's 4.05%. Are we good with that? It's the right question with the wrong numbers. But one of the things about WebAssign is that if I typed that one in, wouldn't it do one of those horrible X's? And then you'd go, wait a minute, and you do it again, you're calculating and say, it's still 7.16. Ooh, maybe I didn't read the numbers right. And you go back and you look at the question, and hopefully I would see it. It's quite easy to see, although you can't. It's in big red letters on the second line. It's not hard for me to see it if I bother to pay attention. Although I'm going to go for a sympathy vote right now. So obviously I'm wearing glasses, or what you don't know, but I'm basically virtually blind in my left eye. Never could see, was born that way. Which means that I'm essentially, I only use one eye to see. The computer, I have two computers. I have the one that has this stuff on it, and then I have the other one to my left. Well, it may look like I'm pointing the other way, but the one over here. And that's on my left side. So when I have to look at things on my left side, I don't always see them very well. And so that's my excuse for missing that one. It's also fun if you ever watch me. Depth perception is difficult when you've only got one good eye. So I was absolutely horrible at any sport involving spherical objects. Kicking balls or hitting balls or jumping up and catching balls or anything else to do with those. Parallel parking is fun because depth perception is really bad. I tend to think things are much nearer than they are. So if you ever see a weird guy parking a car in a space that's like twice as big as it needs to be, but is taking an awful lot of time, good chance it could be me. Because when I'm in the car and I look at the mirror, my brain says, you're going to hit that other car. You're going to hit that other car. I'll then go out and look behind him, 12 feet there. And then I'll go back into my car and I'll sit down and I'll try it. And within seconds of me sitting down, my brain will tell me, you're still going to hit that car. Okay, let's move on. Now, in the next one, we're going to, show you a slightly different version of this table. So let's pretend, right, that we have a response, and the response that you can give is going to be you're very happy, you're pretty happy, or you're not too happy. I guess there was other choices, but that's only 3 that you're going to be like. And so we went and asked some people that question, right? So we stopped people in the street and says, how do you feel today? And we said, this is your choices. Are you very happy? Are you pretty happy? Or you're not too happy? And in this particular question, they're calling it count, but I would really just call it frequency because it is. And I'll make up numbers. Oh no, I won't. You have to be honest with this. So I'm going to use you to collect my data. It'll take me a few minutes to get this up and running. Right. So do you notice at the bottom, there's a thing that, what's it called again? Oh, you've disappeared. Here we go. At the far right-hand corner, can you see a guise that's called reactions? You see the little thumbs up thing? Right. So you are going to take part in this. So let me do a included. So 2, 4, 5, 10, 15, 20. There are going to be 24 of us. Okay. Thumbs up. Those people who are very happy today. Miserable shower. There's 3 of you. How many of you are pretty happy today? I think that's 11. I'll assume that it is. So they're not too happies. They're going to be 10 of you. Now, if that was our data, which I'm now going to go back and make sure you can see it. Right. This is our data. We could make a bar chart out of that, right? But what we're going to do is we're going to add another column. And this column is going to be called relative frequency. That's its typical name. Now, relative frequency can be sometimes a percentage, and some other times it can be a decimal. It really depends on what they want you to do. In this case, we'll do percentages. So 3 out of 24 gets me 12.5%. 11 out of 24, that gets me, yikes, that's an ugly answer. 45.8%. Let's just do it to 1 decimal place. And 10 divided by 24 times 100, and that gets me 41.7%. Now, isn't this information essentially the same as that information there, right? It's just different ways of writing it. Now, one of the checks that you can use when you create one of these tables is that the total should add up to 100%, shouldn't it? Does that make sense? It should add up to 100%. Sometimes, unfortunately, it doesn't. But there are 2 reasons why that can happen. Couldn't one of them be just screwed up like I've done, and one of your calculations was just wrong, all of them? And the second is, can't you sometimes round off and it adds up to 99.8 or 99.9 or 100.1? That's okay. If you get a number that's 100 or darn close to 100, that's really a good indication that you've probably done all the questions correctly. Because isn't it very difficult to make 2 different mistakes that kind of balance exactly each other off? So it's just a quick way check. Now, if I was going to do, oops, Got too many windows open here, so I don't know what the heck I'm doing. Excuse me for a minute, I've lost one of my windows. That's not the one. Good. Now, where's my other window? I've lost a window. The joys of computing. There. Are you looking at the whiteboard with all that? You might well have been looking at that all the time because it was hidden behind two other windows, right? Now, if you take that, if you use this information, can you imagine you'd have very happy, pretty happy, not so happy? And I'm making no attempt to do accurately, but couldn't your answer look something like this? Wouldn't that be your bar chart using this information? And the top number here would be 11, right? So you'd go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. But couldn't you do a bar one with this one? And it would be V, P, and N. And wouldn't the only difference be that wouldn't this scale be percentages? So it would be like 10%, 20%, 30%, 40%. But both these bar charts are essentially the same information, aren't they? In one, you just do very happy, 3 boxes tall, and the other, very happy, and you make it 12.5% tall. And you choose a vertical scale that works on it. So what that tells us is that both of these are quite, are equivalent. So why do we even need the second one in particular? Well, it's to make comparisons easier. So suppose I had two classes. I'll call the first one class A, and we'll call the other one class B. And we ask them the same questions, right? You're very happy, you're pretty happy, and you're not too happy, right? And the ones that we got are 3, 11, 10, with a total of 24. And then we got 12.5%, 45.8%, and then 41.7%. And that came to a total of 100%. Right, so that's our class. And then I went and done the same thing to my second class. But the problem with comparing is, can you imagine that the second class had a different number of students in it? And when the two, we call them samples, are different sizes, isn't it much more difficult to say, oh, this class is happier than that class, or this class is sadder than that class? Because the raw data is, well, there's 15 of them, which is bigger than 11. But isn't there 29 of those in that class? So you'd expect more people to be in all the categories, wouldn't you? So you can't make an easy comparison. On the other hand, won't the percentages be a fairer way to compare the two groups? So the relative frequency would be the best way. So I would go, let's do this one, 4 divided by 29, which is 13.8%. 15 divided by 29, that's about 51.7%. And 10 divided by 29 was 34.5%. Now, when you look at the two classes now, would you agree a larger percentage are very happy, a larger percentage are pretty happy, and fewer are not too happy? So wouldn't that be good evidence that my second class is a much happier group than you depressing lot? So I think you need a joke. You ready? David, do you have a joke before I tell one? You're not saying anything, David.
Not right now.
Okay. Did I forget? I have such a bad memory. Did I tell you the one about the light bulbs? No. Alison, you're nodding your head. Did I tell you a light bulb joke? No, okay. How many psychiatrists does it take to change a light bulb? Only one, but the light bulb has to want to change. Oh, come on, Autumn. That was a... Oh, Mark appreciated that one. Oh, Autumn, not so much. Okay. For those who work in the shipyards then, how many shipyard workers does it take to change a light bulb?
I have a funny story about this.
Okay. Daniel, you hold that thought.
My-
Okay. Don't. Well, let me finish the joke then. The answer is 10. One to change the light bulb and the other 9 to do the paperwork. Okay, what you
Yeah,
got for it? Go
so-
for it, Daniel. What you got?
Okay, so my dad, he's a nuclear engineer, and so there's this one light bulb in the reactor compartment that if it goes out, it would literally take 29 people to change that light bulb. And that's like the minimum based on like all the people who have to approve paperwork and all the different routes it has to go through. So it was kind of crazy to figure that out.
Oh, God. Isn't it bad when reality follows jokes? Yeah, now, the next time I ask you lot, are you happy? You better be a lot more in the very happy group, or I'm going to tell you more jokes. So you have been warned. No, that didn't scare any of you. Okay. Any questions so far? That's pretty straightforward. Well, maybe taking me longer to explain than you'd want me to. We good? Okay, so let's continue then and look at what these questions would look like in the homework. Here it goes. I'm going to have to get 3 monitors. That's what I'm going to have to do. And that way I can put one of these windows somewhere else. Right, so the one we're looking at right now is in a survey, participants were asked, would you say that you were very happy, pretty happy, or not too happy, right? Like the one we did. The results were 731. Pretty happy was 1247. And not like you, miserable lot, only 326 of them were in the not too happy group. Now, we need to get those guys. Let's just take one of them, for example. If I want to find the relative frequency, it's 731 divided by, well, unless I've missed it, won't we have to add these together because they never wrote it down anywhere. So I'm just going to hit some buttons and hopefully I'll get that right away. So it's 731, then another 1247, and then another 326, and I get 2304. So 2304. You wouldn't be doing this like that, wouldn't you be doing that on paper? And then you multiply the whole thing by 100, right? So 731 divided by 2,304, and the answer I get is 31.7. So far, so good. Now, can you see that down here, they want us to draw a bar graph of the percentages. So it's definitely going to be one of these 4 pictures, right? Now, couldn't you just finish this table off and on a little bit of scratch paper, do a very basic bar chart and then say, is that one, or whatever it ends up being? Since we've got the salt button, let's see what that does. Well, there's same table. If I then go to charts and tell it responses, there, can you see our little bar chart's done instantaneously and we don't need to spend time on it. So it's up to you. You know, some people just prefer doing it by hand, and that's fine. Now, here we have a table where it's a little bit more detailed, because what we have is men and women, and we asked these questions. So in a survey of 2010 students, done, I should say, in 2010, students in a statistics class were, how do you prefer to use your cell phone, to text or talk? So you got to pick one or the other. And 104 of the women, 23, so 104 goes here. 23 said they like to talk, and 81 text. And of the 86 in the men's group, 35 said they prefer to talk, and 51 of them decided to text. So this particular table is called the categorical table. It's basically got two different variables, right? Men and women, whether they like to talk or text. In this question, I would describe the men and women as the explanatory variable, and whether they talk or text more, I would call that the response variable. Now, for women, calculate the percentage who like to talk. Well, for the women, won't it be 23 out of 104? Right. So I'm doing that on my calculator, 23 out of 104, and to one decimal place, that ends up being 22.1%. And then for women, what percentage like to text? I am lazy. I like efficiency. And I like it when I can count. How do I know that's the answer, even although I haven't done the calculation?
Because it adds up to 100%.
Right, so if you see a shortcut, shouldn't you take it? I mean, it's not much of a shortcut. You can hit the buttons almost in the same amount of time. Now, based on this raw data, do you think a higher percentage of men like to talk on their cell phone than women? About the same amount or less? Now, if you just look at the raw data, would you agree it's a little bit harder to tell? But I think I know the answer. What do you think it might be?
Percentage wise, yeah, I'd say more men prefer to talk than women prefer to talk.
I would agree with that. So let's find out. It's 35 out of 86. And that's what, about 40.6%. And then you go to this one, so that's there's 60, take away that, so it's 59.4%. So based on this table, wouldn't you say that we've managed to prove that there is a definite difference between how men and women use cell phones? Now, not an earth-shattering response. Nonetheless, it would certainly make I don't know who, telephone companies interested, because if you're trying to get customers and you want to appeal to, say, males, right, to buy your phone or use your system, when you push how clear the voice is, how good the reception is, and things like that. Maybe if you want women, maybe you would say unlimited texting or something, right? You would put something that would encourage them because they like to text a lot. So this information could be put to that. And then you can finish that sentence. For our last question of today, let's look at this very complicated categorical data table. Here we have the seatbelt use, and here we have the usual school grades. And each of these red numbers represents how many students fall into that particular category. So the students who never wear a seatbelt 54 of them get A's and B's, 31 of them had a C, and D and E's are 16. And the total for that row is 101. So if you only looked at that first row, couldn't you turn these numbers into a percentage to see what percentage of people who never wear seatbelts, fail a class? Now, if you, and I'm making this up, I would assume, and I think the data shows it, but you'd have to turn it into percentages, that people who always wear seatbelts, would you agree that a lot of them get good grades and very few of them get bad grades? Which is probably reflecting the fact that intelligent people mostly wear seatbelts all the time. And risk-taking people or dumb people don't. Because you could be a very intelligent risk taker and just not wear seatbelts, right? And couldn't you also be a very careful but not very academic person, right? So it's not a either or, it's a larger percentage do this compared to the other group.